Hello gems! Welcome back to another video of mock test series. This is the ultimate grind for BITSAT 2022 and today we are discussing mock test paper 4. Those who haven't checked out the previous videos of the mock test series wherein we discuss paper 1, paper 2 and paper 3, do check out the description box. The playlist link will be available in the description box of this video. I'm saying so because this paper is slightly set up on a higher level, so I would recommend if you watch the previous 3 episodes first and then come over here. Okay, so with that being said, let the grind begin. Question 1 and 2 over here, let's dive straight into it. In question 1 we are told that if the temperature of a body increases from 300 kelvins to 900 kelvins, the rate of energy radiation increases by. Okay, so this is a simple application of Stephen's law. You can actually do it mentally. If you see the temperature becomes 3 times, right? Stephen's law basically says that the power radiated, which is a rate of energy in this case, so power radiated is directly proportional to the fourth power of absolute temperature, right? So temperature, if you see, becomes 3 times. 300 3s are 900. So power will become 3 to the power 4, which is 81. Okay, so option A, 81 is the correct choice over here. Okay, but let's write it down for those who didn't understand. So I said Stephen's law says that power is proportional to the fourth power of temperature. This is what I meant. So if we take the ratio P1 by P2, it will become T1 by T2 raised to power 4. Okay, so T1 is 300, T2 is 900. Okay, P1 is the original power, P2 is the power radiated or rate of energy radiation in the second case when the temperature becomes 900. Okay, so this is raised to power 4. If you cancel this out, you'll get 3 times, right? 300 3s are 900. That is what I said. So P2 is what we are supposed to find. P2 is 3 to the power 4 P1, right? Power becomes 3 to the power 4 P1. Okay, so that is 81 times of P1, which is the original power. So 81, so your power increases by 81 times. Okay, so option A, 81 is the correct choice over here. Let's come to question number 2. Okay, so let's picture it. Okay, so here we have a whistle which has a frequency of 500 hertz. Now this whistle is tied to a string of length 1.2 meter and it is rotated in a circle. Okay, the radius of the circle being this 1.2 meters. Okay, and there is a listener who is standing far away from this. Okay, somewhere at point P maybe. Okay, so listener will of course hear changes in frequency, right? He will hear the apparent frequency due to the relative velocity, right? Due to the velocity of your uh, whistle, right? It's the whistle is rotated, so at this point it is coming forward. At this point, if you see, it's going back, right? At this point it is approaching the listener. At this point it is departing away from the listener. Okay, so he'll hear different range of frequency. Okay, you are supposed to tell within what ranges will he hear the frequency. It is given that the speed of the sound is 340 meters per second. Okay, so of course he will hear a lot of range of frequency. The frequency will change at every instant because the velocity is changing at every instant, right? But the range, okay, the range will be given by this velocity and this velocity. Okay, why am I saying so? Because this is the velocity when the whistle is entirely approaching your person, right? It's entirely approaching your observer. Okay, and this is the velocity wherein your whistle is entirely departing away from your listener. Okay, and in this case, suppose you take any random case, here we have velocity like this. Okay, only this component of the velocity will contribute, right? So this is theta, suppose, so only v cos theta will contribute in this case. Okay, any other random velocity, whereas in this case the entire v is contributing. Here also entire v is contributing. So this will give you the maximum frequency when it's approaching, maximum frequency when it's departing. Okay, so this two will give you the range. This is the maximum frequency, this will give you the minimum frequency. All the frequencies over here will be in between them. Okay, so that is the basic idea over here. Here also when it's departing away, the frequency range will be between those two frequencies. Okay, so this is the maximum frequency that you will get and this is the minimum. Okay, so let's solve it now. So the apparent frequency basically will be here we'll have the velocity of sound. Okay, here also velocity of sound, and observer is stationary, so plus or minus v0. Okay, and your source is moving, right? Source is moving. So first of all, we'll take this case of approach. So we'll say it's minus v naught. Okay, we'll say velocity of sound, velocity of sound. Okay, or I'll just use v because you might confuse it with velocity of source. Okay, this is the velocity of source. Okay, the whistle is your source, right? So in this case, it's approaching, so it's minus. It will try to increase the frequency or decrease the denominator over here and increase the apparent frequency. I hope you know the concept. Okay, so here in the second case of departure, it will be plus sign over here. But first, let us solve this. So this will be 340 upon 340 minus the velocity at this point. The velocity at this point, how will you find that? It will be given as v equals r omega. Okay, r is, if you see, 1.2, omega omega is not given. It revolves at 400 revolutions per minute. Okay, so omega, this is not omega, this is your f. Okay, it's frequency, revolutions per minute. Okay, so 2 pi into f. Okay, f is 400 and per minute. Okay, so you have to divide it by 60. Okay, I'm doing a lot of mess over here, but please excuse that. Okay, fine. So you can cancel 6 with 0.2, and this if you calculate will be around 50. Okay, so it's 50 meters per second. So 340 minus 50, 340 minus 50, that is 290. Okay, and that into the original frequency of the whistle, which is 500 hertz. Okay, so this will give you an answer around I guess this is the maximum, right? So it will give you an answer around 586 hertz. Okay, so you'll have to calculate this. I know this is a lot of work to do. And the second case is the case of departure. All the frequencies in between will be in between them. Okay, this will give you the departure one will give you the minimum frequency. Okay, so v minus v by vs into, here it will be plus, right? Because it is departing away. Departing away, it will try to increase the denominator and decrease the frequency. Okay, decrease the apparent frequency. So if you solve this, basically you'll have to put 340 divided by 340 plus 50, right? V is 50, so that is 390. And if you solve this, you'll get an answer around 436. So option D is the correct choice over here. Okay, so I know that is a lot of work to do. Let me just summarize that. So you'll just consider the two velocities. Okay, one which is approaching and one which is departing. All the velocities in between will be in this range, okay. So yes, for this you apply Doppler's effect, for this you apply Doppler's effect, okay, and find the apparent frequency. We found it by using omega r. Okay, omega is here and r is this length, right, the radius of, or the length of the string in this case. Okay, so let's move to the next set of questions now. 3 and 4 over here. In question 3, we have two plates, cutlery, not physics. Okay, so two plates having a potential difference of 800 volts are separated by 2 centimeters. A particle of mass this remains suspended between these two plates. You are supposed to tell what is the charge of this particle. Tell it in terms of E, where E is 1.6 into 10 to the power minus 90, right? So let us imagine this first. It's actually very simple. So the plates are at a potential difference of 800 volts. So of course there is a field between them, an uniform field, right? So here we have a particle with some charge. We don't know, we have to find, okay? And its mass mg is acting in the downward direction towards the center of the earth. And here the electric field force, what is that? QE is balancing it. That is why it is remaining suspended in the air. So basically you'll have to equate mg and QE, okay, because the particle is suspended, so that its mass is balanced by the force due to electric field. Okay, and when you equate this two, you can easily find the charge Q, right? So you just have to do mg equals QE. First of all, what is E? E we can find it as delta V by the distance, right? The field is uniform, so you can directly use this delta V by D. Okay, so delta V, the potential difference is 800 separated by a distance of 2 centimeters, so 2 into 10 to the power minus 2. Okay, so this will be 400, and we can actually write it as 4 into 10 to the power 4. This will go on top as 10 to the power 2, and this 10 to the power 2. Okay, so 4 into 10 to the power 4 Newton per Coulomb. Okay, now coming back over here, let's substitute the values and find the value of Q. Okay, so M is 1.96 into 10 to the power, what is that, minus 15, G is 9.8. Let's put it as 10 so that calculations are simple. Q we have to find, and E is 4 into 10 to the power 4. Okay, so actually this can cancel. 4 4s are 16 and 4 9s are 36. So 0.49 into here we'll get 10 to the power. From this and this will become minus 19. So I can write it actually as 4.9. I'll utilize this. So this into this is 4.9. Yes, this is 10 to the power minus 15 and divided by 10 to the power 4, which becomes 10 to the power minus 19. Okay, so that was simple. Now if you compare it with the E values, the closest is 3 times of E, right? 1 E is basically 1.6 into 10 to the power minus 19. If 1.6 times 3, 16 3s are 48, right, which is 4.8. Here we are getting 4.9 basically because we used 10 instead of 9.8. Okay, so option B, 3 E, 3 times of E is the correct choice over here. Okay, so this is 3 times of E would have been if this was 9.8. Okay, so let's come to this one now. At what angle theta from the horizontal should an object be projected so that the height which it reaches and the horizontal range both are equal? Okay, equal horizontal height, horizontal range and height. Okay, what am I saying? Okay, so height, so basically you'll have to equate the height and the range, the two formulas. The formula for height h max is u square sine square theta. I hope you know it. By this time you should know it. So u square sine square theta by 2g, and range what is that? U square sine 2 theta by g, right? So you'll just have to cancel some stuff. G and g will cancel, u square and u square will cancel. Okay, now we can write sine 2 theta as 2 sine theta cos theta, right? So sine theta and this sine theta will get cancelled, and you can actually see, are we missing something? Okay, here there is a 2. Okay, and you can see sine theta by cos theta, which is tan theta. Tan theta will be equal to 2 times of 2, which is 4. So theta will be tan inverse of 4. Okay, and that is option B. So option B, yes, B again, that is the correct choice over here. Let's move to the next question. Question 5 and 6 over here. In question 5, we have a body of mass 1 kg which is executing SHM. Its displacement in centimeters is given by this equation. You are supposed to tell what is the maximum kinetic energy that this body can attain. Okay, so first of all, you might know in SHM the velocity goes on varying. Its maximum at the mean position, and what is the value of the maximum velocity? It is given as a omega, right? Basically the magnitude, if you consider, it's a omega, right? So when the velocity is maximum, of course the kinetic energy is maximum. So you'll just have to find the maximum kinetic energy as half m into v max square, right? So basically you'll have to find a omega from here. Okay, so v max, first let us find v max. It is basically a omega. A is 6 centimeters. Okay, the displacement is in centimeters, so 6 into 10 to the power minus 2. And omega, if you compare this with a sine omega t plus 5. Okay, so omega is nothing but 100, right? So that is 10 to the power 2. So basically the velocity is 6 meters per second. Okay, we converted everything into meter. So maximum kinetic energy naturally will be half m is 1, v square is 6 square, 6 into 6. Okay, this will be 3 6 are 18, so 18 joules. Okay, so option B, 18 joules is the correct choice over here. Quite a straightforward question. You're just supposed to know this and know this. Okay, so let's come to this one now. Okay, this one is a good one. So we have a positive charge Q which is projected in a magnetic field. The magnetic field has this width. Okay, it's limited up to a certain region. The width is around mv by under root 2 qb. Okay, so we have magnetic field in this region. Okay, and this width, okay, this width from here to here. Okay, here this way it extends infinitely, okay, along this direction, but here the width is just mv by 2 under root 2 qb. Okay, we have a positive charge q which is projected with a velocity v in this magnetic field. Okay, you are supposed to tell what is the time spent by this charge in the magnetic field. Okay, so as you can see, this is not sufficient for it to complete the circle, right? This charge with velocity v and charge q with velocity v will describe a circle with radius r equals mv by qb, right? This is the radius for charge q, which is moving with a velocity v and is projected in a magnetic field b, okay? But if you see, this width is less than the radius, right? So this charge will not be able to complete its circle, okay? It will only complete an arc and leave at this point like this, okay? So it will only be able to complete an arc of that circle, okay, of radius this, okay, because this length is not equal to radius, it's less than radius, okay? It's root 2, right? Root 2 by root 2, okay? So it's less than this value, okay? So it will complete an arc but not that circle, okay? So actually you can complete this arc, okay? Just imagine the circle. Here we'll have the radius r, and here also we'll have this as the radius r, right? This is the arc of that circle, okay? R being mv by qb, okay? So now there is actually a standard way of doing this question. We can find this theta. We know sorry, we know the time period for complete circle is 2 pi m by qb, right? So we can find this angle theta, that will give us how much angle it has transversed, okay? So for 2 pi we require time period, right? For 2 pi angle for complete circle we require 2 pi m by qb. So for this angle, what is the time needed, okay? So we can linearly compare that because angular velocity is constant over here, okay? Anyways, let's come to this. Let's find theta now. How can we find theta? Okay, I'll drop a perpendicular from here, okay, from here at this point, okay? So you can see that this is nothing but, this distance is nothing but r, right? That is r, okay? And this distance is, no, we won't consider that. This distance we know at the width, okay? The width, okay? So we can write sine theta because we know the opposite side and we know the hypotenuse. So sine theta will be basically this, sine theta will be opposite, which is mv by under root 2 qb, and divided by hypotenuse, which is r, which is mv by qb, okay? So mv by qb will cancel. Sine theta is nothing but 1 by root 2, or this angle is nothing but pi by 4, 45 degrees. Sine of 45 is 1 by root 2. So theta is nothing but 45 degrees or pi by 4, okay? So we know that for 2 pi, for completing a circle, the time period is 2 pi m by qb, right? We'll call it as t only, okay? So for an angle pi by 4, what is the time period? Okay, so you can easily see that this is divided by 8, right? 2 pi by 8 will give you pi by 4, right? So this is, left hand side is divided by 8, right hand side also you'll have to divide by 8, okay? You know that t is 2 pi m by qb, t is 2 pi m by qb, and that you'll have to divide by 8, so that will give you pi m by 4 qb, okay? I hope you are able to follow. Please rewind and watch it again if you are not able to follow. It's simple. You're just supposed to find this angle. For an entire circle, it's 2 pi m by qb. For this angle, it is t by 8, okay? The specific angle, it is t by 8. So divide t by 8, okay, and that will give you your answer, okay? It's a standard way of doing this type of question, okay? So let's move to the next question now. Question 7 and 8 over here. In question 7, we have a YDSC setup. Okay, the slits are 2 millimeters apart and are illuminated by photons of 2 wavelengths. We are using 2 wavelengths in this experiment. One is of 12,000 angstroms and the other one is of 10,000 angstroms. Okay, you are supposed to tell at what minimum distance from the common central bright. So basically, they'll form the common central bright, right? So at the center of the screen we'll have the common central bright due to this wavelength and also due to that wavelength, okay? The central bright will be common, okay? It will be at the center of the screen, right? So at what minimum distance from the central common central bright on the screen, which is 2 meters, so capital D is 2 meters from the slit, okay? Now you're supposed to tell, will the bright fringe from one interference pattern will match or coincide with the bright fringe from the other interference pattern, okay? This might seem complex, but stick with me, it's very simple, okay? So basically you are supposed to tell when will the bright fringe from one interference pattern due to one wavelength will coincide with the bright fringe due to other interference pattern, which is due to this wavelength, okay? So basically you'll have to equate y1 is equal to y2. y1 and y2 are the distances on the screen. Okay, we'll suppose this is the setup over here, the two slits, the center of the screen over here at O. Y is basically this distance, okay, that you measure from O, okay, from the central bright. So y, which is y1 is the bright fringe of the first interference pattern, y2 is the bright fringe of second interference pattern. They both coincide, means they are at equal distance from O. Okay, so this is what you're supposed to do over here. And bright fringe, you know that y is given as n lambda capital D by small d. Now it's for the first one, so we'll use n1 lambda 1. Okay, point to remember over here is d is same for both, right? This distance is same for both, whether you use this wavelength or this, the setup is the same, right? And this, since setup is the same, this two d's are same for both. Okay, so you need not worry about that. The only thing that will change over here is the wavelength is changing first of all, and n will also change because it is not mentioned that fifth bright of this will match with fifth bright of that. Okay, n will not be the same. Okay, n1 of this will match with the fringe number, basically will change. So fifth of the first one may match with the sixth bright fringe of the other. Okay, you don't know. Okay, so of course it will be different, okay, because we are using different wavelengths. So it will be n2 here, for the second one it will be n2 lambda 2 capital D by small d. Actually this is a special case. For bright fringes to coincide, you can directly use the formula n1 lambda 1 is equal to n2 lambda 2. The smarty pens among you might directly know it. Okay, so this and this will cancel. So you could have directly used n1 lambda 1 is equal to n2 lambda 2. Okay, so yes, now let us do it. So n1 by n2 will be equal to, if you see, okay, this will tell us something. Okay, hold on. So this will be lambda 2 by lambda 1. Lambda 2 is 10,000, 10,000 by 12,000, 3 zeros cancel, 2 5s are 2 6s are. So 2 5s are and 2 6s are. Okay, so what does this tell us? This tells us when you bring it in the simplest ratio, right? 5 by 6 is the simplest ratio. You cannot simplify it further. It says that the fifth fringe of the first, so fifth fringe of the first interference pattern matches with the sixth fringe of the second interference pattern. Okay, fifth fringe of the first interference pattern matches with the sixth fringe of the second interference pattern. This is what it tells us. Okay, yes, and this will be the minimum case because you have brought it in the simplest ratio. Okay, if you want to know the next one, you can just multiply this numerator and denominator by 2. Okay, so this will give you 10 and this will give you 12. So the 10th fringe of the first one will match with the 12th fringe of the second one, but that is not the minimum one. The minimum is 5 and 6. So fifth one of the first one and the sixth one of the second one will match with each other. This is the data that we have found, but at what distance will they match? Okay, that is what we are asked. Okay, the minimum distance from the central bright at which they will coincide. So you are supposed to find y1 or y2. Okay, so you are just substituting over here. So what will you do? Y1. So in place of n1, you can now use 5 because you know the fifth fringe will match, or fifth fringe of the first pattern will match with the sixth fringe. So fifth fringe of the first pattern is over here and sixth fringe of the second pattern is over there. Okay, so we'll find only one. The distances basically will be equal. So fifth fringe of the first pattern, right? So where is it? That will be our answer. So 5 lambda capital D by small d for the first pattern, right? So lambda 1. So 5 into lambda 1. Okay, remember if you had to use lambda 2, it's the sixth fringe. Okay, so 5 into this is 12,000 into 10 to the power minus 10. Okay, can I do it somewhere else? Okay, I'll do it here only. 5 into 12 into 10 to the power, this is plus 3 and minus 10 minus 7 into capital D, which is 2 meters. 2 meters divided by 2 millimeters. So 2 into 10 to the power minus 3, this and this will get cancelled. 12 5 is 60, 60, and this will be 10 to the power minus 4, 60 into 10 to the power minus 4, or 6 into 10 to the power minus 3, which is 6 millimeters. Okay, this is meters, and 10 to the power minus 3 meter is millimeter. Okay, so it's as simple as that. You can remember n1 lambda 1 is equal to n2 lambda 2 for two bright fringes to match. Okay, simplest ratio means, yeah, the minimum one. Okay, the minimum distance. Okay, so now let's come to question number 8. Here we have blocks A and B. Okay, so I think I forgot the diagram. Okay, let me draw it. So here we have block A and B. A is of 3 kgs and B is of 7 kgs. Okay, and we are told that B is placed on a smooth horizontal surface. There is, however, friction between the two blocks. Okay, so between the two blocks we do have friction, but there is no friction between the block B and ground. Okay, so the maximum force that can be applied to this lower block B, so that both of these blocks move together, both of them move together means both of them will have the same acceleration since they are beginning from rest. Okay, anyways, that is not needed or maybe needed. So that force is 49 newtons. So if you apply a force greater than 49 newtons, they will slide among each other. Okay, B will move faster than A and there will be sliding. Okay, if you apply 49 newtons, they will move together. That is the maximum force. Okay, if you apply below 49 also, it's okay, they will move together, but above 49, you can't do. Okay, so you are supposed to find mu between A and B. Okay, it's actually very simple. Actually, usually the question is framed like you are supposed to find this maximum force for which the two blocks move together. That is the concept of block over block. We actually discussed it in one of the concept capsules. I'll put it up over there because it is one of the favorite topics of your BITSAT. You can check out that video. Okay, so let's write FBD for block A and block B. So basically Fnet is equal to MA for block A and block B. Okay, so if you see block A is only moving due to frictional force between A and B, right? When you apply 49 newtons to block B, what is happening? B wants to slide. Now since there is a tendency of relative motion, block A is pulled due to block B. Okay, so block A is moving due to that reason because there is friction between A and B. When you push B, block A is moving with it because friction is pulling it. Okay, because it is the friction is opposing the relative motion over here. Okay, so the only force on block A is the frictional force. Okay, so frictional force, you can write it as mu times of N, right? And this will be also your Fnet, which you can write it as mass of A into acceleration. Now the acceleration will be same in both the cases, right? They are moving together. They move together means they have the same acceleration since they are beginning from rest. Okay, so mu, which we want to find. Okay, and N will be over here. So what is N? N is this normal reaction which will be equal to mg in this case. Okay, which is mass of your block into g. Okay, so N will be equal to mg. Now I'm directly substituting mass into acceleration. So mass of that block A is 3 kg. Okay, and here mg again. So 3 kg into g. G, I'll take it as, I think let's take it as 9.8 only. So 3 and 3 will get cancelled and you get A is equal to 9.8 times mu. Okay, or you can actually divide A by 9.8 to give you mu. Okay, let's apply it to block B. So basically you'll get two equations in terms of A and mu. You'll solve them and that will give you your answer for mu. Okay, so for block B, what are the forces? For block B, it's a little bit subtle. If you see, we have a K over there, that is not subtle. But if you see the forces, the two forces over here for block B are, first of all, we are pushing it with a force of 49 newtons. And there is of course sliding between the two, right? Block A and block B. So friction is pulling it back. Okay, or you can see Newton's third law happening over here, right? Equal and opposite forces acting on two different bodies. Okay, so this friction force is acting on A in the forward direction. Equal and opposite force will act on B in the opposite direction. Equal and opposite. Yeah. So frictional force will act on this. So what is happening? B is sliding forward. A does not want it to slide. You can imagine it that way. So it's kind of pulling it back. Okay, so that is the frictional force. Okay, so you can write F net is equal to ma. The motion is in the forward direction, so this 49 newtons, which is the force applied, minus the frictional force, is equal to the net force, F net, right? F net you can write is equal to ma, right? Mass of this block, which is 7. I hope you are able to follow. Into acceleration. Acceleration is same. They are moving together. Okay. Now, frictional force, actually we could have directly substituted it from here. Okay, but now let us solve it this way. Okay, so 49 minus frictional force, if we have to substitute, it will be 3 mu into 9.8. Okay, from here I'm putting mu into n, so mu into n is mg, right? M into g, and 7 times of a. A is actually, we can write it this way because we want the answer in terms of your mu, right? We want to find mu. Okay, we are not concerned about a. Okay, so let's write it as a. We can write it as 9.8 times mu. Okay, so if you see 49 is, so you can take 9.8 times mu common, so 9.8 times mu, and this is 7, and 3 will go to that side, plus 3, right? 7 plus 3, 10. Okay, so this is now it's simple, 98 times mu, and here we have 49, so mu is 49 by 98, and that is 0.5. Okay, yes, 98, yeah, 49 to 2 is 98. Okay, so option C, 0.5 is the correct choice over here. So write equation F net equals ma for block A and block B, and then solve. We'll get equation in terms of A and U, acceleration and coefficient of friction, and here also acceleration and coefficient of friction. Okay, so solve them, and that will give you the value of mu. Okay, you can also find the value of a from here, substitute, and you'll get the value of a, but that is not asked in the question. Over to the next question. So question 9 and 10 over here. In question 9 we have an aeroplane which is flying horizontal with a velocity of u. Okay, of course it's flying at a height in the horizontal direction. The height is 2000 meters. So when it is vertically above a point A, okay, so it's vertically above a point A, a packet is released, PUBG vibes. Okay, so the packet strikes the ground at B, and AB is 3 kilometers, and G value you are given. You are supposed to tell what is the velocity with which your aeroplane is moving. Okay, so basically let's picture this. It's moving u in the horizontal direction with velocity u at a height of 2000 meters. Okay, now this is point A. Suppose this is the point where we are going to release that packet. Okay, and it will strike the ground. The packet will fall like this. Okay, it will continue with the velocity of the plane, and finally it will strike the ground at B, right? So this distance is given as 3 kilometers or 3000 meters. Okay, you're supposed to tell what is this velocity u. Okay, so first of all, what we'll do, we'll find the time of this journey. Okay, the time taken for the packet to fall from here to here. Okay, so basically you can find the time in the vertical direction only. You can just use time is equal to under root 2h by g, because if you see in the vertical direction there is no velocity. The packet only leaves with the velocity of the plane which is in the horizontal direction. So the packet lives with u velocity in the horizontal direction, and there is no velocity in the y direction. So basically using s is equal to ut plus half at square, ut is 0, right? So through that you can finally find t as under root 2h by g or 2s by g. Okay, so this will give you 2h, so 2 times of your height, which is 2000. Okay, divided by 10, g is 10, this and this will cancel. 2 200s is 400, 400 root is 20. Okay, so the time taken for the packet to fall is 20 seconds. Okay, this is the time taken in y direction. No, time is independent of frame of reference for small velocities. Okay, so yes, time taken in y direction is the time taken in x direction. Okay, time does not depend on the frame of reference. Okay, so packet falls from here to here, the time taken is 20 seconds. Okay, 20 seconds is the time for entire journey. It's not like it falls for 20 seconds and then it will move like this. Such a thing does not happen, right? The time goes simultaneously. Okay, so basically the time taken for this journey, okay, from here to here is 20 seconds. Okay, although we just used the y direction, time is independent of frame of reference. Okay, so yes, this is the motion that's happening and the time taken is 20 seconds. So basically if you see in the x direction, it's only velocity u and distance is 3000 meters. So you can use distance is equal to velocity into time, right? This is the distance it has traveled with this velocity in this time, right? 20 seconds is the time it has moved this distance and this distance. Okay, so combined it looks like this. Okay, So in the horizontal direction, if you see, it has moved a distance of 3000 meters with this u velocity, and time taken is this. So simply you can easily find u from here. So 3000 divided by your time is 20, and that will give you u. Okay, so this and this will cancel, so 150. So 150, this is meters per second, remember that. Okay, so everything is in meters per second, so it's not 150 over here. You'll have to convert it into kilometers per hour. I hope you know the conversion factor. Basically, if you want to convert 1 meters per second into kilometers per hour, or vice versa, if you want to convert kilometers per hour into meters per second, so 1 kilometer per hour is 5 by 18 meters per second. Okay, so this is the conversion factor. Usually we want to convert kilometers per hour in meters per second, but in this question we'll want to convert meters per second into kilometers per hour. So we'll use this factor. So basically we are cross multiplying it, so it will become 18 by 5. It's 5 by 18 over here, goes on the other side, 18 by 5. So you'll have to multiply this with 18 by 5. Okay, so what is that? 18 by 5. So this is 30 and 18 threes is 540. Okay, 18 threes is 54. So that is 540 kilometers per hour. Okay, and that is the correct choice over here, not 150. Okay, this 150 is in meters per second. This was just to confuse you and to make you answer this in a hurry. Okay, so please don't be in a hurry. Okay, so let's come to question number 10 now. We have a conducting loop which is placed in a uniform magnetic field. B is given, okay, and its plane is perpendicular to the loop. Okay, so basically you have this loop and the magnetic field is like this. Okay, plane is perpendicular to the field. Okay, now the radius of the loop is made to shrink at a constant rate. So radius is shrinking. So what is happening? The flux is changing through the ring, and where this is going, you're supposed to find the induced EMF. So induced EMF is basically the rate of change of flux, right? d phi by dt. Okay, so first we'll have to find rate of change of flux. Flux is basically b dot a, right? b a cos theta. Okay, so theta, if you see, magnetic field is will take the magnetic field in the outward direction. Okay, just for simplicity. So magnetic field is along this direction, and we have our what is that, loop. Okay, so loop, and its area vector is also along this direction. Area vector is perpendicular to the area, right? So magnetic field is in this direction, area vector is also along that direction. Okay, so the angle between the two, the angle between magnetic field and area vector is 0, right? Both pointing out. So angle between them, they are parallel. 0 cos 0 is 1. So we are just concerned about B into A. Okay, so now A, this is a circular loop. Okay, I must say this is a circular loop. Okay, and it is shrinking. Okay, so it's a circular loop, so area is pi r square. Okay, so that much data we have. So induced EMF magnitude wise is d phi by dt. Okay, so let's substitute that. So B is constant, B will come out of this. So d by dt of area pi is also constant, but let's first write it that way. So B and pi will come out of that derivative sign. The derivative of r, if you see, r is changing, right? The radius is shrinking with time, so it's changing with time. So derivative of r square is 2r, and very, very important, dr by dt. Okay, applications of derivative vibes. Okay, so yes, you are supposed to differentiate that as well, dr by dt, right? Because it is not in terms of dr, it's in terms of dt. So dr by dt, that factor also remains. So it's the derivative of r square basically is 2r dr by dt. Okay, derivative of x square with respect to x is x square will become 2x, but x square with respect to t is 2x dx by dt. Okay, so this factor also remains when you divide, when you differentiate with respect to some other factor. Okay, here we have dt. Okay, anyways, that's a little bit of math over there. Let's come to this. So 0.025 pi will keep as it is, because we see it in most of the options. Into 2 into r is radius of the loop. So you are supposed to tell induced EMF when radius is 2. So at this instant the radius is 2 centimeters, which is 10 to the power minus 2. Okay, and dr by dt is 1 millimeters per second. So 1 millimeters is 10 to the power minus 3 per second. So fine. So this is 4, okay, 4, and if you move this will be 10 to the power 3, this 1 2 3, 10 to the power 3, this and this will get cancelled, 25 into pi into 4, okay, and we also have, I guess, this, right, 10 to the power minus 2, 25 into 4 is 100, 100 into 10 to the power minus 2, that is, are we missing something? Let's check. So 2r, 2r, so b we have, pi we have, this we have 2r, r is 2 centimeters, 2r dr by dt. Okay, I think the answer should be pi. Let me check. Yes, pi is the correct choice over here. Let's move to the next question now. Question 11 and 12 over here. In question 11, we are given that the resistance of a wire at 20 degrees Celsius is this, at 500 degrees Celsius is this. You are supposed to tell at what temperature will the resistance be this. Okay, so it's actually very simple. If you know the dependence of resistance on temperature, so resistance at the particular temperature is given as R0 plus R0 times of alpha into delta T. Okay, delta T is the change in temperature, alpha is the coefficient, so I can take R0 common over here, so it will give me 1 plus alpha delta T, right? Now let us write equations for these two. Okay, that will and using those two equations we'll find the value of alpha will help us in the computation of this. Okay, so first of all, let us write it for the first one. So first one, the resistance is 20 ohms, and R0, let us write it as it is, and 1 plus alpha, which we want to find, and the temperature changes 20. Okay, so this will be 20 alpha. Okay, now for the next one, the resistance is 60, okay, at temperature 500. Okay, so R0 into 1 plus 500 times alpha. Okay, so we'll divide 2 by 1, so 60 by 20 is 3, R0 and R0 will get cancelled, and this will come in the numerator, so 500 alpha upon 1 plus 20 alpha, so this will give us 3 plus 60 alpha, and that will give us 1 plus 500 alpha. Okay, so if you see, it will be 2 is equal to 440 alpha, or alpha is basically, okay, alpha is basically 1 by 220, okay, per degree Celsius. Okay, so 1 by 220 is the value of alpha. Okay, what we are supposed to find, we are supposed to tell at what temperature will the resistance become 25 ohms. Okay, so again we'll have to use the same procedure. First of all, we'll take this equation, okay, because I don't want to compute the value of R0. We can actually compute if you substitute and all, but let's not do that. Okay, so I'll consider one equation from here, this one. Okay, and one more we have to write, at what temperature will the resistance become 25. So resistance becomes 25, R0 as it is, R0 into 1 plus alpha will substitute in a while, into delta T. Delta T is what we are supposed to find over here. Okay, what should be the rise in the temperature for the resistance to become 25. Okay, so now let us divide this by this. Okay, what will we get? Let me do that over here. Okay, so if I divide this by this, R0 of course gets cancelled, 5 and 4, so yes, 5 4s are 20, 5 5s are 25, and here we'll have 1 plus alpha into delta T, and divided by 1 plus 20 alpha, 1 plus 20 alpha. Now just solve it. So 5 plus 100, or is it, yeah, 100 alpha is 4 plus 4 alpha delta T. Okay, now this will be 1 and 1, and this will be alpha. Now actually we can substitute 100 divided by 220, which is that is 10 by 22, or here we have 4 alpha delta T. Okay, so 100 divided by 220, which is 10 by 22, or I can write it as 5 by 11. 5 by 11 plus 1 is 16 by 11. Okay, and 16, and that will cancel, so 16 by 11 is equal to 4 alpha delta t, right? So 4 and this will cancel as 4. Okay, so 4 by 11 is alpha into delta t. Finally, we can bring this alpha to the other side. So 1 by alpha is delta T. Okay, that is the temperature that we want to raise. Okay, so alpha 1 by alpha basically is 220, right? 1 by alpha will be 220 because alpha is 1 by 220. Okay, so this is 220, this is 11 2 za 0 za, so this is 80 degrees Celsius. Okay, so the temperature rise should be option D, 80 degrees Celsius, in order for the resistance to become 25 ohms. Okay, I think that was simple, just a bit lengthy. Let's come to this one now. De Broglie wavelength of a proton, charge is given, okay, and mass of the proton is also given if it's accelerated by a potential difference of 1 kilovolts. Okay, de Broglie wavelength is given as lambda is equal to h by mv, or h by p directly. Mv is momentum, right? Now momentum can be written in the form of kinetic energy, which is under root 2 mk, right? Momentum in form of kinetic energy, where k is kinetic energy. The mass is given. Kinetic energy, how will you find kinetic energy? It is accelerated by a potential difference of 1 kilovolt. So kinetic energy is nothing but q times of v. Okay, actually you could have used h by mv also. H by mv, v you can find it using half mv square equals qv. Okay, from here you can find this v, but it will become too complicated, so that's why I'm using directly kinetic energy. Kinetic energy will be q times of v, the charge into the accelerating potential. Okay, so this will give us kinetic energy, right? When you multiply your charge is this, and your um, accelerating potential is 1 kilovolt. So if you multiply that, it will be 1.6 into 10 to the power minus 3 from this, so minus 16. Now you'll have to substitute this over here. So substitute everything. H is 6.6 into 10 to the power minus 34. Under root 2 m is 1.6 into 10 to the power minus 27 into kinetic energy, which is 1.6 into 10 to the power minus 16. Okay, you'll have to solve this. I know it's a bit too much, but the answer that you will get is option B. Okay, 1.6 and 1.6 will come out. This is even, so you can remove it out. Under root 2 is around 1.4, and yes, you can solve that and you'll get some answer, and that answer should be 0.9 into 10 to the power minus 12 meters. Okay, yes, that is the correct answer. Let's move to the next question now. 13 and 14 over here. In question 13, we have an iceberg of density this, which is floating in water of density this. This is the density of water. You are supposed to tell the percentage of volume which is exposed outside water. Okay, so suppose we have an iceberg like this. Okay, some portion of it is exposed. So you are supposed to tell what is the volume, the percentage of volume which is exposed outside. Okay, now you can see that iceberg is floating, right? So the upthrust which is provided by the liquid, the water, is balancing its force mg. Okay, that's why your iceberg is floating. Okay, so upthrust equals mg. That is what we are supposed to use, and upthrust is also given as v rho g, right? Where v is volume immersed, rho is the density of the liquid, and g is acceleration due to gravity, and this is equal mg. Okay, so g and g will get cancelled, and you can find the volume immersed. Okay, so you can find this volume. This is the volume immersed. Okay, so from this equation we can find the volume immersed. Okay, and if you subtract total volume minus volume immersed, that will give you the volume that is exposed. Okay, as simple as that. So volume immersed, and here we have density of water, which is 10 to the power 3 kg per meter cube. Mass of the iceberg, you can write it as mass is density into volume, right? So density of the material of the iceberg, which is density of iceberg is this. So density into volume of the iceberg. Now this is total volume, right? Total m is total mass, so this is for total volume. Okay, so density into total volume. Now if you see volume immersed is, if you divide 900 by 1000, that is 0.9. Okay, so volume immersed is 90% of the total volume. Okay, 0.9 is nothing but 90%. So volume exposed is nothing but 10% of the total volume, right? So this is volume immersed, which is 90%. Yes, the major portion of it is immersed, and only 10% of it is exposed. So option C, 10% of the volume is exposed. Okay. Now let's come to this one. We are given that total energy of an electron in the first excited state of each atom is this. Okay, you are supposed to tell its kinetic energy. Very, very simple, because there is a direct relationship between total energy and kinetic energy. So kinetic energy, if I want to write, kinetic energy is negative of total energy. Okay, so total energy is minus 3.4. So kinetic energy will be 3.4 electron volts. Okay, and if you're curious, the relationship between potential energy and total energy is 2 times of total energy. Okay, so if they had asked for potential energy, the answer would have been minus 6.8. Okay, just 2 times of this. So potential energy is 2 times of total energy. Kinetic energy is just the negative of total energy. Okay, remember, kinetic energy can never be negative, so you can just neglect these two options, half mv square, v square positive, m positive, right? Let's move to the next question now. So question 15 and 16 over here. Question 15 from the semiconductor and your communication part. Okay, so here we are told that a common emitter configuration amplifier, and it has a voltage gain of 50 and input impedance. So the resistance of the base input side is 100 ohms, and the output impedance of the collector, which is 200 ohms. Okay, you are supposed to tell power gain of this amplifier. Power gain basically is the ratio of output power to input power, right? Power is first of all given as V square by R, right? We want everything in terms of V and R, voltage gain, and R is also given, so we'll write power as V square by R. Okay, so power gain will be voltage gain, voltage square gain, okay, divided by the impedance gain. Okay, you cannot call that a gain. Basically gain is ratio of output to input. Okay, so output resistance to input resistance. Okay, so this is what we are looking for. So power gain will be simply the voltage gain square, so 50 into 50 divided by output resistance to input resistance. Output divided by input, that is 2, so this into 25, so 25, 125, 125 and 0. So 1250 is the correct choice over here. Let's come to this one. We have filled a balloon with helium gas at 27 degrees Celsius. This pressure, the volume it occupies is this, and now will change the temperature and pressure. Temperature is changed, pressure is changed. Now what will be the volume occupied? Okay, so you are just supposed to use PV is equal to nRT for 2 times. So P1 V1 is equal to nRT1 in the first case. Okay, and then R will remain constant. Number of moles will not change. Okay, you are only changing the temperature and pressure. Number of moles depends upon the number of molecules, right? So that won't change. So in the second case, we can write P2 V2 is equal to nRT2. Now you take the ratio of both. So P1 V1 by P2 V2 is equal to T1 by T2. What are you supposed to find? We are supposed to find V2, right? Volume in the second case. Okay, so let's substitute now. P1, the pressure in the first case, 1 atmosphere. Okay, I'll not change the units, everything is in the ratio, it will cancel. V1, volume in the first case, 500 meter cube. Okay, P2, pressure in the second case, 0.5 atmosphere. And then V2 we are supposed to find, we'll send it to the other side, and this will become T2 by T1, T2 by T1. So T2 is the temperature in the second case, place it in kelvins. So this plus 273, that is 270 divided by, so T2 by T1. So temperature in the first case 27, so that is 300. Okay, so here we go. So I can multiply this actually. So 500 into 270, what I'll do, I'll multiply 10, so I'll get 5 into 30, this and this I'll cancel, 3 9s are 27 and 5 hundreds are, so yes, 9 into 100, it is 900 meter cube. Okay, so V2 is 900 meter cube. Over to the next question. Question 17 and 18 over here. In question 17, we are supposed to find the ratio of the intensity at the center of a bright fringe to the intensity at a point which is at 1/4 of the distance between two successive bright fringe. Okay, so 1/4 of the fringe width. Okay, so we are supposed to find, first of all, intensity at the center of one bright fringe and at a distance 1/4 of the bright fringe. Okay, so at a distance of 1/4 basically. So we directly know that the intensity at the center, basically intensity at any point, is given as I naught cos square phi by 2. Okay, where phi is the phase difference. Okay, phase difference between the two wavelengths that are coming over there, right, at that point. Okay, so we are supposed to find the intensity at the center, which we know to be I naught, which is 4 times the intensity due to each slit. Okay, but we are not concerned about that. So I naught is the intensity at the center, we already know that. And the intensity at your 1/4 distance from the 1/4 distance of the slit, basically the fringe width. Okay, so basically, how do we, first of all, how do we know that the intensity at the center is I naught? Because phi at center is 0. Okay, there is no phase difference between the two wavelengths that are coming at the center. Okay, so no phase difference means phi is 0. So phi is 0, or so that cos 0 is 1, and you get basically the intensity at the center of a bright fringe to be I naught. Okay, now at 1/4 distance, the basically the path length, the path difference will be lambda by 4. Okay, for a path difference of lambda, we have a phase difference of 2 pi. Okay, basically you can imagine it like this. So for a path difference of lambda, so this is 1 lambda, right? This is one wavelength. So for a path difference of lambda, this is an entire phase, right? 2 pi. This is 2 pi. Like basically you can make a circle out of it. So that's 2 pi. Imagine that way. Okay. So for lambda, we have a phase difference of 2 pi. So for lambda by 4, which is the phase difference between the two rays meeting over here, right? So for that, we'll have to divide this by 4. So lambda by 4 will be this by 4, which is pi by 2. Okay, so this is the phase difference for two rays which are meeting at 1/4 distance from the central bright. Okay, the center of the central bright, or center of the bright fringe. Okay, so I is equal to I naught cos square. So phase difference is pi by 2 over here. Okay, so pi by 2 by 2, which is pi by 4. Okay, and cos pi by 4 is 1 by root 2, 1 by root 2 square, 1 by 2. So I naught by 2. Okay, this is the intensity at 1/4 distance. Okay, and this is the intensity at your center is I naught. Okay, we are supposed to tell the ratio. Okay, so I naught, so I by I dash is basically I naught divided by I naught by 2, which is 2, right? I naught divided by this, 2 will go on top, and the ratio is 2. Okay, let's come to this one. We have a rectangular block of mass m, which is put in a liquid, okay, of density rho. So let's imagine that. Okay, so first of all, it is in equilibrium. We are going to displace it from equilibrium. We are going to push it, suppose some distance x, and it undergoes oscillation. And to be specific, if x is very small, the oscillations will be SHM. Okay, you are supposed to tell what is the time period of this oscillation proportional to. Okay, so basically time period of an SHM is given as 2 pi under root m by k. This k you can find using basically the equation of SHM is f net. So f net in SHM is minus kx, right? So you can find k from here, and your time period is inversely proportional to the under root k. Okay, so that is what we are supposed to find. So first of all, this is not in equilibrium. When we displace it, what will happen? We'll just push it in a certain distance x. Okay, suppose it was initially a distance in. Okay, so under equilibrium condition, it was a distance in. So what was happening? Suppose this is equilibrium condition. So where can I write it? I'll need space. So here I'll write equilibrium. So in equilibrium, what is happening? Upthrust is balancing mg. Okay, so mg is balanced by the upthrust. Upthrust is the volume immersed. Volume is, so area of base, we know it as A, area into the height, which is immersed. Volume immersed, right? So only this volume is immersed. So A into A. So this is the volume immersed. Rho, density of the liquid, which is rho into G. Okay, so basically you can see. So under equilibrium, this is the case. Okay, now if there is no equilibrium, okay, suppose we are displacing it, we are pushing it a distance x inside. Okay, so this distance becomes a plus x. We have pushed it. Okay, we have displaced it from equilibrium. So what will happen is that there will be a net force this time. Okay, so what will happen? Net force will arise. So that will be mg minus upthrust. Okay, so due to these forces are no longer balanced. Earlier they were balanced. Upthrust equals mg. Now we have displaced. So upthrust will be more. Okay, so because more portion is immersed, right? The portion upthrust depends upon portion immersed. Now more portion is immersed, so upthrust will be more. Okay, so yes, so net force will be given by their difference. Okay, so mg, if you see, mg is as it is, minus upthrust. Upthrust now volume immersed is area, which is a times basically a times of a plus x into density of the liquid, which is still rho, and g. Okay, so here you'll get mg minus, now just open that up, a rho g. Okay, and minus, okay, again you'll have ax rho g. Okay, a rho g and ax rho g. Okay, so if you see mg and a rho g are equal under equilibrium condition, if you see, it's mg equal to a rho g. Okay, so these two are equal, and f net basically is, so the net force basically is minus a rho g into x. Okay, so I have expressed the force in terms of kx minus kx. So k value is nothing but a rho g. Okay, k value is a rho g, and time period, as you know, is inversely proportional to 1 by k, or 1 by k, and k is over here a rho g. Okay, so if you see, we have the correct relation over here. It's inversely proportional to the area of cross section. So option B is the correct choice over here. Okay, this one not correct, so this one not correct. Okay, so option B is the correct choice over here. Okay, over to the next question now. Question 19 and 20 over here. In question 19, we have three charges which are placed at three vertices of an equilateral triangle of side A. Okay, the force, you are supposed to tell the force experienced by the charge placed at vertex A in direction normal to BC. Okay, so we are only concerned about the force which is normal to BC. Okay, so either in upward direction or in downward direction. Okay, we are not concerned about the horizontal force. Okay, only the vertical component of the force. Okay, so if you see the symmetry in the figure over here, okay, did I just say symmetries? Is the answer 0? Yes. Okay, so let's see how it is 0. Okay, so plus q, so here the force will be in the outward direction, right? Like charges repel. Okay, and this, if you see, the force will be towards the other charge, right? And these two forces will be equal. They will have the same magnitude. Basically, F will be k q square by a square, right? The distance is the same, a, and basically the magnitude is the same, q. Okay, although the sign is negative, the sign just shows the direction of the force, right? Here it's towards and here it's away. Okay, so magnitude wise the forces are the same, so F and F. Okay, as shown. Now we are only concerned about the vertical component. We are supposed to find the net force in the direction normal to BC. Okay, so if you see, I'll split this up. This angle will be 30 degrees, right? The entire angle will be 60 degrees. This will be 30 degrees, half of that angle. So here we'll have F cos 30. And here also, if we split it like this, we'll have F cos 30. This is vertically opposite angle, so this is also 30. So we'll have over here F cos 30. So F cos 30, F cos 30, both are equal and opposite forces. They will cancel out each other. Here, of course, the two forces, the two component of the forces add. Okay, so the net force on this charge is not 0, but the net force in direction normal to BC is 0. Remember that. Okay, so these two forces, the upward force equals downward force, and they the two of them cancel out, and the answer is 0. Okay, so yes, option C, 0 is the correct choice over here. Okay, now we have question 20. Here we are given that the activity of a radioactive material at t is equal to 0 is R0. Very good piece of information. And it is R0 by E when the time is 5 minutes. Okay, so basically if you see, this is the activity at mean life. Okay, this is mean time. Okay, mean life. If you see, the activity becomes, or the concentration becomes N0 by E when the time is mean time, right? Mean life. Okay, so basically this is mean life, what is given to you. Okay, even if you were not able to decode that, you could do it the primitive way, R is equal to R0, e to the power minus t lambda. Okay, that way also you could do, and solve that equation. You'll get the same answer of what I'm getting now. Okay, so basically I know that this t is equal to 5 minutes is the mean time, okay, or mean life, whatever you call it. Okay, mean, because mean time. Okay, now the time in minutes when the activity reduces to half of its initial value. Okay, so basically you are asked for half life, right? Half life. So half life, basically, right? When does the activity reduce to half? When the time becomes equal to half life. Okay, or the basically when the concentration becomes half. Okay, which is half life. Okay, so you might directly know the relation between your half life and mean life. So half life is basically 0.693 into tau. Tau is your mean life. Okay, so yes, 0.693 is basically a way of writing log to the base e2. Okay, we write it in decimal form as 0.693. Okay, and tau is tau, if you see, is tau is, we just said that it is 5. Okay, mean life is 5, so 5 log to the base e2. Option D is the correct choice over here. Over to the next question. In 21 and 22 over here. In question 21, we have a plano-convex lens which fits exactly into a plano-concave lens. So somewhat like this structure we get. Okay, so let me draw it big. So plano-convex lens which fits exactly into a plano-concave lens. Okay, so the parallel surfaces. Okay, so plane surfaces are parallel to each other if lenses are made up of different refractive index. So first one is mu1 and this one has mu2. You are supposed to tell also the radius of curvature is given as r. You are supposed to tell the focal length of this combination. Okay, so basically first we'll have to find f1, focal length of the plano-convex lens, then the focal length of the plano-concave lens using lens maker formula, and then we'll have to add their reciprocals, right? That is how we get the equivalent focal length, right? So let's do that. So first of all, for the first one, so 1 upon f1 will be mu1 minus 1, right? Lens maker formula I'm using. So for the first one, which is plano-convex, right? So the first surface that light will bounce on is the plane surface. So 1 by infinity minus 1 upon, so if you see this, the r is on the opposite direction of the incident ray. Okay, so it's r is in this direction. If you complete the sphere over here, it will go in the backward direction. R will be in the opposite direction to that of the incident ray, which means it is minus r. So minus minus, and this will become plus. Okay, so you get mu1 minus 1 upon 1 by infinity is 0, and here you'll have r. Okay, so 1 by f1 is mu1 minus 1 upon r. Okay, now 1 upon f2 is equal to, this is for the plano concavo. Okay, so that one, yes, so this will be mu2 minus 1. Now we are considering the medium, the surrounding medium, to be air. Okay, so that's why I'm not dividing it by the medium density, the refractive index of the medium. Simple reason. So now the light ray will be incident on this surface first, which is the concavo surface. So that is 1 by r1. R1 is again negative, right? R is in this direction, opposite to the direction of incident ray. So minus r, minus 1 upon r2. R2, if you see, it's the plane surface, right? So 1 upon infinity. Okay, so 1 upon f2 is basically mu2 minus 1 into minus 1 by r. So I'll flip this in the numerator and I'll get this. Okay, so basically the equivalent focal length excuse me, so equivalent focal length, the reciprocal will be equal to this, the sum of this reciprocals, right? So here we'll get mu minus 1 upon r. So basically r in the denominator, and we have mu minus, is that r? So r, mu1 minus 1, and again mu1 minus 1 plus 1 minus mu2. Okay, is everything correct? I hope so. So this is minus mu2. Okay, so if you solve this, what do we get? We get this will cancel, right? Minus 1 plus 1, and we'll get mu1 minus mu2 upon r. Okay, this is the reciprocal of the equivalent focal length. So the equivalent focal length will be ulta of that, okay, reciprocal of that, which is r divided by mu1 minus mu2. Okay, yes, that's correct. Let's move to question 22 now. We are supposed to tell the charge on the capacitor in steady state. Okay, each of the capacitor has the same capacity, so the charge will be the same. Okay, so charge is basically given as C into V, right? So our first objective should be to find V, right? The voltage across the capacitor, right? If you see, all these are parallel connections, so whatever the voltage across this will be the voltage across this, right? So first of all, let's find voltage across the 4 ohm resistor. Okay, so if you see, in steady state, this is completely charged, no current will flow in that branch in which capacitor is connected. So this is like an open circuit. Okay, when the capacitor is charged, no current flows. Okay, so in that branch which contains the capacitor, so this is like open circuit. Okay, so current will flow only in this part of the circuit. Okay, so the current I, basically it will go around this path, so I will be given as V by R. So V is 5 and effective resistance is 4 plus 1, right? They are in series, by the way, same current passes through both. So 4 plus 1 is 5, so current that is drawn from the cell is 1 amperes. Okay, so 1 amperes. So voltage drop across this, you can easily find it as V is equal to IR. So I is 1 and current, your resistance is 4, so 4 volts. So 4 volts drop across the 4 ohm resistor. Okay, so 4 ohm drop across the capacitor as well, right? We have two capacitors here, no current is flowing, right, between, so the resistor is good for nothing. Okay, in both the cases. So here the potential drop across these two capacitors is 4 volts. So the potential drop across each capacitor is 2 volts, right? 2 volts across this and 2 volts across this. Okay, so basically your because they are identical, so 2 volts. Okay, so the charge is given as C into V. C is what is C? 3 microfarad. 3 into 2. Okay, so that is 6 microcoulomb. Okay, because this is in microfarad, so 6 microcoulomb. Option B is the correct choice over here. Over to the next question. So question 23 and 24 over here. In question 23, we are given a block over block system like this. Okay, mu between the two blocks is given as 0.2 and mu between the block B and ground is given as 0.3. Okay, you are supposed to tell what is the minimum force required to move block B. Okay, again we are just supposed to draw the FBD for block B. Okay, you can easily see that we'll push it with the force F or pull it with the force F. Then there will be friction between A and B, right? This is the friction between the two blocks, and also there will be friction between the block B and the ground. Okay, F dash. Okay, so the minimum force that is required to move block will be the sum of this, right? When F is basically greater than or equal to, in certain cases, okay, greater than or equal to this sum. Okay, and the minimum force we can just call it to be equal, right? Actually this should be greater than this opposing forces, so as to move that, but the minimum we can treat it as equal. Okay, so let's find that. Okay, so first of all, friction between the two blocks, friction between the two blocks, F is given as here it will be, N will be in this case 100 into G, right? N will be due to the above block mg, right? So friction will be mu m mass of the A block into G. Okay, so here mu will be 0.2. Okay, 0.2 in the first case, m is 100, to G is 10. So I think this into 10 to 2 into 200. So this is 200. Okay, and F dash, which is the second friction, the friction between the block B and ground. Okay, now if you see, the normal reaction in the second case will be due to both the blocks, right? So it will be the sum of the masses of both. Okay, so it will be 100 plus 200, which is 300 G. Okay, the both of those blocks are placed on ground, right? Although only one makes contact with the ground, the normal force is due to the weight of the both, right? So it is due to 300 G. Okay, so mu So basically n is 300 G, that is what I'm saying. Okay, so mu is first of all 0.3 between the ground and your block B into 300 G. So 300 into G is n, so this into 3 into 300, which is 900. 900 plus 200, these two forces you add, that will give you the minimum force that is required to move the block, which is 1100. Okay, so here we have a uniform rod of length L and mass m, which is free to rotate in a vertical plane. Okay, so we have a rod like this, mass m and length L. Okay, so it's free to rotate in the vertical plane, so it can rotate like this. Okay, in the vertical plane. Now it is released. Okay, it is released. You are supposed to tell what is the angular acceleration. So it's just released like this. Okay, suppose it was supported like this, now it's released. Okay, you are supposed to tell what is the angular acceleration. Okay, it's very simple actually. If you see, we can assume that the entire mass of this will be located at the center of mass. So here we have mg. Okay, the center of mass will be at the uh, geometrical center, which is L by 2. Okay, so yes, we can find the torque in two different ways. We can write torque equals I alpha, right? And torque can be also written as R cross F. Okay, R cross F. So first we are writing torque equals I alpha. Now torque we can write it as R cross F. R is, so that is L by 2, and F is, okay, F if you see is mg, right? And R and F are perpendicular, so RF sine theta, which is 0, right? Oh, sorry, RF sine theta sine 90, which is a 1. Okay, so need not worry about the sine factor. So F is mg. Okay, so just solve this. Alpha you are supposed to find. Now you are supposed to know the moment of inertia about this axis for a uniform rod. Okay, and it is ml square by 3, right? That is ml square by 3 for about this axis. Okay, if it's about this axis, then it's ml square by 2l. Okay, please remember that. So mg L by 2, and we have ml square by 3. Just solve this. Alpha will be cancel. L and L will also get cancelled. 3g by 2l. 3g by 2l. Right. So option A, 3g by 2l, is the correct choice over here. Over to the next question. Question 25 and 26 over here. In question 25, we are given a circuit, and we are also told that the heat produced in the 5 ohm resistor is 10 calories per second. Okay, you are supposed to tell what will be the heat produced per second in the 4 ohm resistor. Okay, actually you can do V square by R over here. Okay, heat produced per second, it's like power radiated, or V square by R into T. Okay, so that way you can do. So potential difference here and here will be the same. Okay, so here you can find the potential difference. This potential difference you can split among the two, and you can find directly the heat that is radiated through the 4 ohm resistor. Okay, but that is a long way. If you see, there is a pattern in the question. Okay, here it is 5 ohm resistor, and here if you combine this two, 6 plus 4, 10 ohm. Okay, so if the current here was I, the current that would have passed through this. Okay, suppose the current that is passing through this directly, let us consider that, is I, then the current which will pass through the other branch will be I by 2. Because the resistance is double, the current will become half. Basically V1 I1 is equal to R1 I1 R1 is equal to I2 R2. What am I saying? Okay, so just like that, if we take the current over here as 2I, this will be half of that, it will be I. Okay, so first of all, let's apply I square RT over here, heat radiated, because we know what is the heat radiated in the 5 ohm resistor. So I square RT, I is 2I, so I square R is 5 ohm into T is 1 second, heat produced per second. Okay, so T is 1. No need of writing that, but let's, okay, so this is, if you see 5 and this will cancel as 2, and here we'll have 4I square, right? So this will be 0.5. So I square is nothing but 0.5. Okay, let's keep it at I square. Okay, let's not root that. Okay, here we can find the current through the heat radiated in the 4 ohm resistor as I square RT again. So I square is uh, I square is 0.5, R is 4 ohms, and T is per second. Okay, heat radiated per second. So zero point 0.4, which is 0.5, which is half into 4 is 2, so 2 calories per second. Okay, so 2 calories, let me check that. Yes, 2 calories per second is the correct choice over here. Now let's come to this one. Here we have a particle. Its acceleration as a function of time is given, so the acceleration is varying with time. Okay, where f naught and t are constants. Okay, f naught and capital T are constants. The particle at t is equal to 0. Okay, basically the velocity at t is equal to 0 is 0, and the instant when f is equal to 0, you are supposed to find the velocity. Okay, when the acceleration becomes 0, you are supposed to find the velocity of the particle. Okay, so that is our job over here. So first of all, we can write acceleration. Now this is acceleration, right? So acceleration, we can write it as dv by dt. Okay, now it's only in the x direction, so need not worry about the other um, terms. Okay, so f naught into 1 minus t by tau. Okay, if it was moving in multiple directions, then you had to go for partial derivative, right? Anyways, now it's only moving in the x direction, so you can directly find dv by integrating. So I'll take t to the other side, and I'll open this up, f naught t by t. Okay, this into dt and integral of that. Okay, I'm basically integrating. So here v will get integration of dv as v. Okay, initial velocity will assume it at 0. Okay, here we'll get f naught t, okay, minus f naught by t is constant, and here we'll have t square by 2. Okay, now we are told that when f becomes 0, we are supposed to find the velocity. Okay, velocity of the particle. So first of all, when f becomes 0, okay, what will be the time? Okay, so that is what we are supposed to find. So first of all, let's put f is equal to 0 in this equation. So it either means f naught is 0 or this is 0. F naught cannot be 0, it's a constant other than 0. So it means t minus 1 minus t by t is 0. Okay, when f is 0, this term is 0. Okay, it means that your basically t is equal to t. Okay, when you solve this, you get t is equal to t. So in the final equation, basically your acceleration becomes 0, f becomes 0 when t is equal to t. So you're supposed to find velocity at this time. Okay, when small t is equal to capital T. So basically substitute that, f naught into t minus f naught into t square. So basically capital T square upon t. So basically we'll have f naught t by 2. So it is half f naught t. Okay, and that is option D. Okay, yes, option D is the correct choice over here. I hope it was simple to understand. Over to the next question. 27 and 28 over here, the final two questions, and last two questions will be your homework questions. So let's do this. So here we have a geostationary satellite which is orbiting in a circular orbit of this radius. Okay, the time period of you are supposed to tell the time period of a sky satellite which is orbiting a few hundred kilometers above the Earth's surface. This is the radius of the Earth. Okay, so basically here you are supposed to use Kepler's law. Okay, so we'll say T2 by T1. T2 is the time period uh, of your sky satellite. Okay, basically your time period square is directly proportional to radius cube, right? This is according to Kepler's law. So T2 is the time period of the sky satellite divided by the time period of the geostationary satellite, 24 hours. That squared is equal to R2 by R1 the whole cube. Okay, R2 is the radius of the sky satellite. Radius, it is 6400 plus 100, but the 100 kilometers would not make any difference. Okay, so basically it will make a little difference, not that much. So I can just consider it as 6400. Okay, R1 radius of your circular orbit, radius of your geostationary satellite, which is 36,000. Okay, and that raised to 3. Fine. And T2 we are supposed to find. T1 is 24 hours, and that is squared. Okay, so T2 squared will be equal to 24 hours into this, and this and this will cancel. 8 into 8 divided by 6 into 6 into 10. Okay, so 2 3s are 2 3s are 2 4s are 2 4s are. Okay, and what can we cancel more? This can cancel this as 2 2s are and 2 5s are. So we are left with 24 square into what do we get over here? 8 divided by 9 5s are 45 whole raised to 3. Okay, so here you'll have to root it. So basically, yeah, here we are getting t2 square. So when you'll root it, you'll get an answer around 1.8 hours, right? This is because we considered this as 6400, whereas it was 6400 500, right? A few hundred meters more. Okay, so yes, the answer will be around 2 hours. Okay, so 2 hours is the correct choice over here. Okay, we are getting 1.8 because we chose this as 6400, which was actually 6400, which is the radius of the earth, plus the few hundred kilometers of the altitude. Okay, now let's come to this one. We have a LR circuit. Frequency is given 50 hertz. L component. Okay, the inductance is 2 Henry. E basically the voltage, okay, of your battery is 5 volts. R is the resistance, value of the resistance 1 ohm. So the energy stored in the inductor, it's quite simple. Energy stored in the inductor is given as half Li square, right? Half Li square. So for that we need the value of I. We already know L, we need the value of I. I will be nothing but E by Z. Okay, here we have impedance. Okay, we have both inductor and resistor, so we have to consider both. So yes, Z in this case will be R square plus omega L square. This is XL square, right? Omega L square. So let's compute that now. So R square, so 1 square, which is 1 plus omega, this is frequency, so 2 pi f, so 2 pi into f is 50, so directly 100 pi we can write. So 100 pi into L is again 2 times, so 200 pi square. Okay, so 1 plus 200 pi square. So you can actually approximate it like it will be only under root of 200 pi square, right? Just approximating it. This is a very big number, right? So here you'll get 200 pi, right? So 200 pi is nothing but pi into 2 is 6.28, so 628. Okay, so 628 around. So basically I will be nothing but 5 divided by 628, right? E is 5 and divided by 628. Now you can easily find the energy. Energy will be half Li square, so half L is 2 and I is this. So this divided by 628 into 5 divided by 628. This will be this and this will cancel. This will be 6.33 into 10 to the power minus 5, I guess, minus 5 joules. So which is option D, none of the above. Okay, so let's move to the final two questions for the day, and that will be it. Question 29 and 30 over here. These are your homework questions. You will let me know the answers of these questions in the comment section below. Okay, the correct answer of course receives a heart from me. And by the way, question 29 is one of the questions that we solved for A series. So you can go check out the video for A series and you'll find the answer over there. And question 30, okay, I'll give you a clue. It's not a question from SHM. Okay, SHM won't help you in this question. So don't do SHM. Don't try solving this question through SHM. Do anything but SHM. Okay. So yes, that's all for today's video. I hope you enjoyed it. If you did enjoy it, smash that like button. Just a personal news about me to whoever it concerns. Basically, I am shifting, so the new video will be from a new studio. Okay, this is so overwhelming for me because this home has been a place of memories. Okay, I've been in this home for like 14-15 years of my life. I started staying here since kindergarten maybe, and now I just turned 20, so I have spent like 14-15 years in this house, and I'm leaving all of it behind over here. And I'll see you soon in the next video. I don't want to cry. Keep enjoying physics.